Hello guys, this is our second class for chapter 4, fluid kinematic. But before starting this class, let me talk about the plan for next week. So the deadline for homework 3 is done. You have to submit your homeworks, and I guess you did. And also homework 4 is released. You have time till next Wednesday. But I unhide the homeworks 2 days sooner than the previous one, like Monday, I guess, to give you more time to start working on it. The reason is that next Wednesday we have a review class, and Friday we have midterm. So in Wednesday, and also chapter 7 that this homework is for, the homework 4 is for chapter 7, is part of the exam. But since everything is very tight, the time is tight, and we don't have time to give you the feedback of that homework. So it would be better for you to work on this homework soon, start it soon, and maybe this weekend, and come to my office hours during Monday and Wednesday and submit it before the Wednesday midnight. And then you will have time Thursday to review the solution and Friday and make yourself ready for the exam. That's one thing that I have to just give you a heads up. And the second one is that some of the students just reach me out that about they don't have time or they have a conflict exam and they couldn't participate in the midterm exam in the Friday. And I made a Google form sheet to find a match time between these students. But if anyone else also has a problem that couldn't participate in the exam Friday and wants to enroll in the makeup exam that is Sunday or any day when we find a match, the week after that, please send me an email ASAP. Maybe, excuse me, maybe till tonight or at least tomorrow night. And I will add it to the Google form and share with them or her, and then submitted the availability times. I could figure out what time is better for all the students and also myself. That's the second thing. Chapter 4 is not part of the exam. Next week, you don't have any homework. So homework part, you will have the exam next week, and then you have a great weekend, a long weekend. And after that, when you come back in the Wednesday, you will see the homework number 5. And other thing is about the homework, the course, the points that you deducted because of the force by diagram. I know it was a tough homework, and also homework 3, it was a tough questions. It was hard, I know, but that's because we don't have time that much to talk about the materials in detail and also solve more questions for you. That's why, because it's the exam is next Friday, July 1st, I guess. Yeah, and the time is on the syllabus, but if I get it true, it's 2 p.m. Eastern time, and the exam would be 2.5 hours. Yeah, thank you, Anthony. July 1st to 4th. Great. And yeah, it's on the syllabus, and we have, if you have a conflict exam, just let me know. I was talking about the homework. Yes, I know that the average score is low, but that was the only way that I could teach you that the force body diagram is one of, this is a force body diagram is half of the solving any question in the fluid mechanics. So assumptions and force body diagram is the most important one. If you do not draw the force body diagram, you couldn't understand how to solve. Okay. What about that? You think it's not fair? No worry about it. We will have bonus points during the other homeworks, and also no worry about the final score, not at all. Just come with me step by step. You will be happy at the end. I may decide to drop the lowest homework, one of the homework that you got the lowest one, or I may add more and more bonus points to compensate for that. So don't worry about it. Don't need to, I will recreate that for you. But again, if you lose the points about the force body diagram, let's be fair for all the students and consistent for the grading. If you reach me out that, hey, can you just regrade for me? Yeah, I will do that. I'm not that much tough in grading. I will give you more points, but finally, nothing would be changed. Okay? Because if you couldn't understand that your force body diagram is required, when your final answer is 2 and you forgot for the pressure and you forgot to put the units there, you will lose point because 2 is most important. The units is one of the most important thing in engineering, all the engineering and in this level that you are learning, right? So just that was just the thing, that don't worry about the points and your final score. No worry at all. That's a tough course. The fluid mechanics is hard. Everyone knows. And I'll try to give you a better understanding on the concept. Because I was a student like you, I passed fluid mechanics 1, fluid mechanics 2, aerodynamics, and then on my master degree again passed fluid mechanics in the high level or graduate level, and then in my PhD, my first PhD again, I passed this course. Then I came here to UB, again passed fluid mechanics in the graduate level, and then turbulence. After all, I found some of the concepts were wrong at first when I was reading the book. And now I'm giving you that where you may don't understand it correctly. Okay, so again, don't think at all about the scores. You will be happy at that. I assure you. Okay, so we'll talk about the last class. We talk about the continuum hypothesis. That what does it mean? What does it mean that we have a molecules? We'll talk about the meaning of the scales and what is the length scale, what would be the size of the particle and how much it should be compared with the shape characteristic length, and also and the mean free path between the molecules, and how you can say that it is valid to use Navier-Stokes equation or apply any of the Newton's law and rigid body motion on the particles. Then we talk about the first part was the velocity field or field representation for different things, different parameters. And we talk about the Lagrangian Eulerian methods. We found how to find the acceleration field from the velocity and the material derivative. And we stopped before the here is the part of acceleration field, how we drop the equations, and then stop before the Reynolds transport theorem. Okay, so today as you also mentioned before, it would be better for us to solve questions instead of just purely talk about mathematics and formulas. So yes, that's again hard for me since that's a recitation plus the course and I have to merge all things there. But I will do my best to do this. Okay, so today I'm going to solve a bunch of the questions. Just two, but I have two more if I had time. But maybe I don't have time to record the video before or after the class, just for solving the homework. But I can solve that during the office hours for you. If you're coming and ask me that, hey, can you solve, or just bring a question for me, I will solve that for you. Or I also have a review exams with different bunch of the questions. I can share with you guys. That also would be helpful. So that's enough. And we can start for question 1, which is finding the streamline, acceleration, local acceleration, convective acceleration, and plotting. Okay. Okay, so question 1, I'll give you a velocity field. That the velocity is the three components of velocity are ax minus b for u, cy for j, and dt for k. And you can see that one of those is only function of x, not y, nor z. And also it could be part of as a function is a function of t, the w1. As we talked about that before, it could be a function of a location and also the time. So that would be the field representation or velocity field that could be a function of any of these 4 variables. So it asks you just rewrite the formula for acceleration and tell me what is the local and in part A, and what is the expression for convective acceleration. Okay, so let's solve part 1. Yeah, that I have to mention this one, that I made a mistake in, as you may check the Uvillian, I uploaded this question and you may have the PDF file of that. But I made a little tiny mistake at part C for finding the, I'm sorry, part D for finding streamline. I used the acceleration instead of the velocity components. So I solved that problem and I'll delete that PDF file and re-upload it again because that's fixed now. Okay, so let's write the velocity and apply A and B. That's better to do not do that because A and B are like a constant, and don't bother yourself with the numbers right now. Only solve that with the A and B and then finally replace the numbers there. Okay, so velocity is A x minus b for the I and plus cy for the j and dt for the k. Okay, so first you should know that what is the u and v and w. Okay, so you found the u, v, and w. Okay. The second thing is that what is the formula for local acceleration? As you remember, we had dv over dt, the total derivative. That was a local term, that is rho v of derivative over t, and plus v dot gradient of the v. Okay, And we mentioned that this is our local term, local derivative or local acceleration if that's velocity. And then this is convective term or convective acceleration. So in this question, it asks you that first in part A, find the local acceleration and then give me the convective acceleration. So we'll do it one by one. Whenever you have a vector here, like here, the derivative of time, the time rate of a vector, it has to be applied on u, v, and w in 3 directions. Okay, so you can write it that, okay, I have x direction, y direction, and z direction, and then split that to, and you know that when you have x direction, it's I, it's j, and it's w, it's k. So the derivative of vector would be a vector. That's why we have I, j, and k, because it has to be a vector. Then you can say that, okay, what is my component in u, in I direction is u. So I will write it that this is my first term, and this would be my second term and my third term. That's one method. Or you can say that the gradient, the derivative of a vector is 3. I, j, and k. And then put the components. This is the second one, okay? It would be splitted in the directions that would be directly solvable. Okay, so if I write it down in the second form, or tj plus w1 in a k direction, okay? That would be 3 terms of the local acceleration. And now I can replace this with derivative of time for ax minus b. Better to write it in front of it. Then this is going to be e of ax minus b in the I direction plus derivative of time for cy, which is the v, plus d of dt in the k direction. Okay, then apply it and find those that are zeros. This is not a function of t. Then derivative of temperature, the time would be to 0. Also, this is not a function of t, so it's going to be 0. But this is, and the answer is d. So the final answer for the local acceleration is d k, and now you can replace the amount of d, which is 5. The question mentioned is 5. It's 5 meters per second square. And as you can see here, the unit is meter per second square, which is this unit for acceleration. And that's your answer for part A, local acceleration. For part B, your equation is convective acceleration, the gradient dot v dot gradient, gradient also vector, and the dot product of two vectors are, the problem is that the gradient is an operator, okay? In mathematics, it's a high level mathematics, but the gradient is a vector. If you apply the gradient on a scalar, right, like pressure, then gradient of pressure would be a vector. So if you have a scalar here, let's say you have a gradient as a vector of a parameter, okay? If parameter is a scalar, then the answer of that is a vector, okay? But if that's a vector, then its answer would be a tensor. Tensor means that it's not 1D. The vector has 3. It seems that a scalar is a number with the dimension of 0, and vector is dimension of 1, and tensor is dimension of 2. Okay, so the answer of that would be a tensor. Okay, so gradient will add 1 dimension to any parameter, the dimension of the parameter. So a scalar is 0, it will add it 1, and it's going to be a vector. So vector is 1, it will add it 1, and it's going to be tensor. But the dot product is going to decrease one of those. So for example, if you have v dot or gradient dot a parameter, gradient is a vector, and since you have a dot product, this should be a vector, right? Because dot product is defined based on two parameters, two vectors. If you have a scalar, this is not a gradient. This is not a dot product. It's going to be a constant number times a vector. And the answer would be a vector. But you have a dot product here. It decreases 1 dimension. So the dot product between two vectors would be a scalar. Okay, so gradient dot a parameter like a velocity would be a scalar. And here, if you check it out, you will have a gradient of a vector. Then this is going to be your tensor. Okay, so it has dimension of 2. And vector is also dimension of 1. But you have a dot product here, and dot product going to decrease the tensor level from 2 to 1. And that's why the answer would be a vector. What is that vector? Is absolutely 3 direction of acceleration, right? That's why the convective acceleration has I, J, and K. These are only mathematics behind that. And if you're going to work on research on fluid mechanics for the future, you have to understand it, and you have to know, because, for example, doing CFD, for example, all the softwares ask you that what is the velocity, what is the tensor, and you have to know what is the difference between a tensor and a vector and a scalar. And what parameter is a scalar, and what parameter are not a vector or simple or 1D vector, it's 2D vector or tensor. These are things that behind it, and you have to know. But we know that the answer would be a vector, right? Okay, but what is the formula for that? That's the easiest part. This is going to be gradient of the V, and it has 3 directions: X direction, Y direction, and Z direction. Okay, in X direction, that's the way I always write it to prevent any mistake, because those number of parameters or terms are high. So I don't want to have mistake. That's the way I'm writing that. So I started with the V at first with the brackets here, and then I will start with U, plus v plus w. Okay, then u plus v plus w, and u plus v plus w. Why? Because that's the first vector. Okay, it doesn't mean you are splitting this part in the directions. That v, not the others. So these are going to repeat it for all directions. What else? The second part is the gradient, right? So plus is multiplied by round of x, that's the y, and that's z. Again here. And that's going to be repeated 3 times. Okay. Then you're coming out of the term and you need to split the v in u, v, and w. Then you repeat just u here, v here, and w here. That's how you can make 3 terms of in 3 direction acceleration. But most of those going to be 0 based on the assumptions. For example, you have u that is ax minus b. Okay, so u is not function of y and z, right? So these are going to be 0. V is cy is only times as a function of y. So these two are going to be 0. And what else? The w is function of time, right? So all these 3 going to be 0. What finally we have? For x direction, we will have u of x times I. That's the end. Okay, so it doesn't have I here. And we don't have I, j, k here. These are just scalar. These are the components of acceleration in I direction. And you need one I here, one j here, and one k here. So here we have only u times the, and these are zeros. Okay, for the y direction, what we have only v derivative of y. That's the only one. Okay, and in z direction, you have 0 because all are 0. Then if you sum up all together, then you have acceleration. What would be acceleration? Acceleration is a vector. This is only convective term because we found the local acceleration here. The total acceleration would be local acceleration plus convective acceleration. So acceleration here going to be the first term in I plus the second term in j plus the third term, which is 0 in k. And the rest of that would be just doing math and find what is the answer of it. U is a x minus b, and rho u rho x is a. By multiplying these, the first term is a times ax minus. V is cy, and derivative of y is c. Then multiplying these together is going to be c squared y, and z 0. Okay, so what's the acceleration term? The acceleration term, acceleration is convective acceleration. Convective acceleration is the first one, a times ax minus b in I plus t squared y in j plus 0 in k. Any question till now? Okay, so I can apply the numbers as well here. A is going to be 4, A is 2, B is 4, right? 2 times 2 is 4. And then I can write that 4x minus 8, because 4 times 2 is going to be 8 in time I, plus C, which is minus A, and minus A means minus 2, but to the power of 2 is going to be 4. So 4y j plus 0. That's easier to apply the numbers for A and B at the end. So I made a mistake here. I used these two for finding streamlines. That was wrong at first. So I'm sorry. I solved that problem, and now I will write it the correct form for finding streamlines, and also I will upload this one instead of that GIF file. So what is it asks at first, we'll treat it. Calculate the acceleration. So, the part C is also should be fine. Is the calculate the acceleration of a fluid particle located at x equal to x and y equal to 3 and 2. Okay, so before that, let's solve part C, which is the acceleration. Finding the acceleration is total acceleration. So what is the acceleration in general? Is the local term plus the convective term. So local term was 5k. That's the local term plus the convective term. Convective acceleration is here. Minus 8i plus 4yj. And don't write the 0, 1. Okay, so in general, the acceleration vector is 4x minus 8i plus 4yj plus 5k. Okay, now it asks you that if x and y are 3 and 2, so you have point. What would be a at 3 and 2? So a is 4 times 3 minus 8i plus 4 times 2j plus 5k. Vector A is going to be 4i plus 8j plus 5k. And if it asks you that what is the acceleration amount or magnitude of the acceleration, then magnitude would be QRT of the 4 to the power of 2 plus 8 to the power of 2 and 5 to the power. And the answer is 125 meters per square. Any question? Part C, streamlines. How we can find the streamlines? So we talked about that in the class, the last class, that the streamlines equation could be found by V over U. Again, it's for 2D plane. If I ask you that, what is that for 3D planes? This would be different. But for 2D plane, is V over U is going to be dy over dx. Okay, and then also you can write that u dy is equal to nu dx. Okay, what is u? U is 2x minus 4. From where? From ax minus b. A is 2 and b is 4. So 2x minus 4 is your u. And what is v? Is cy. C is minus 2 because it's minus a and a is 2. So minus 2y. I place those here. This is going to be minus 2y. And this is going to be 2x minus 4. Right? So the answer, the form of integral form is 2x minus 4 dy is equal to minus 2y dx. Okay. If you get the integral from each side, this would be wrong because you have y and you are going to say that y is a function of x. For example, y is my independent variable. One of those are independent, the other one is dependent. So based on since it's not a rule, but most all the books are writing like that y is or independent variable. So y is a function of x. Then find y in one side and function of x the other side. But the reason is that the problem is that if you get the integral here, you will take integral in both sides that dy and dx is valid, is available, but you have a term with the x in one side and y in the other side. And that's wrong to consider 2y is a constant number for this integral and 2x minus 4 is a constant for dy. Because if you get the integral, then you will have 2x minus 4 times y here and minus 2yx here, right? And 2xy is going to cancel out with minus 2y or sum up with that. And the final equation is not true, okay? So what should we do? We have to switch this one. Bring all the terms with the x in the point in the side that you have the x for and switch here to here. Okay, then what would be the final form? And also I will multiply that by 1 over 2. Okay, to get rid of the numbers of to cancel out the 2 ones. So what would be finally? If I bring minus 2 here and also at first I multiply that by minus 2. So the answer is x minus 2 dy equal to minus y dx. Then I will do the switching and bring it here. So minus 1 over y dy now is equal to 1 over x minus 2 dx, right? So I have the whole terms, the integral of with the dx, all the functions, a function of x, is okay if you have xy here. It's totally okay. And you cannot split that. You have to find a better way to do the integral. But for now, it's can be splitted. And most of the questions that you have in the exams, these are reasonable integral forms that you can at least separate the terms. If that's not possible, then you have to find pure math, go over the pure mathematics things and the books to find a way to find the integral and find the function of y as a function of x. That would be hard. But right now, these integrals that we are talking over it and the exams, those are reasonable ones. Okay, so if I get the integral of this one from each side, then I will have 1 minus 1 over y dy is equal to integral of 1x minus 2 dx. Okay. So each integral has its own specific constant number. Okay. Because most of the students and most of the time you need to have two constant numbers. It's better, we will see in the next question that why we need to have two constant numbers, but take integral from each side independent of the other side. Don't merge the c's. You will have time to do it later, but it's better to write that at first. 1 over y dy, the integration of that is ln of y, right? So I will say that this is going to be minus ln y. Then plus the constant number c1. Keep that c1. And also on the other side, again, you have ln x minus 2. Okay, this is your second integral plus c2. If you had any constant, any boundary conditions, then that like x and y, then you can say that what is c1 and c2. If you don't have it and you want to find in general form, then you can bring all in one side and write that ln y plus ln x minus 2 plus c2 minus c1 equal to 0. Then merge these two with the constant c, because those are again constants. And also I can write that is ln of c, right? Why? Because it's going to be multiplied all together. For example, if I write it that is ln of c, then final answer is ln of y, x minus 2, and c. Why? Because that's again a rule in mathematics. You have ln is like a log file. It's a log. A logarithm of a plus logarithm of the b is logarithm of a times. These are scalar. And also if you have logarithm of a minus logarithm of b, this is logarithm of a over. These are a reminder from mathematics. So we have ln of c plus ln of another term and ln of y. So all of these is going to be multiplied by each other, right? And what else? What else? I can say that, okay, this is going to be 0, right? I can take the e to the power of each side. Then this ln, when you have e to the power of ln of a term, this is going to be a, right? So I can use this formula and say that y e to the power of ln cy x minus 2 is equal to e to the power of 0. Then this is going to be 1. And the final thing is cy x minus 2 is 1. And then also I can bring c in here and say that x minus 2 times y is 1 over c, and 1 over c is another constant like capital C. What is formula? If you see the books or solution manuals or that professor write the solution for that, suddenly from here you will see that the answer is here. And they don't show you the part by part that how we get that, how we found that ln y plus ln x minus 2 plus a constant is equal to multiplication of these two terms or is equal to constant. How is possible? So the case is that they will assume that these two are merged and then assume that the constant c is ln of that constant and then multiply each and it is equal to 0, then take exponential of each side, e to the power of that, and use this rule to say that e to the power of this term is equal to e to the power of 1, then this is going to be 1 and the ln and e going to be cancelled out because of the rule. And finally, you have this term is equal to 1 and write that, okay, 1 over c again is a constant number. I'll write constant and say that x minus 2 times y is a constant. And that's the equation for Streamline. Y times x minus 2 is equal to. Okay. So it also asks you to plot that for me. Okay. Remember, xy equal to c is a hyperbolic function. Okay. Hyperbolic function plot is like this. These are all the tangential lines. Never touch this one, it just merge. But what is at infinity is going to be cut. But these are the tangential lines. And if xy equal to 0. No, a constant, like 1. If xy is 0, this is going to be 0 and 0. Is equal to constant, then this is going to be your equation or plot. And if you change c's from, if c is positive, this constant positive is here. If c is negative, is here. And you have one side or this side, right? And what else? How you find these two tangential lines? You can say that xy is equal to 0. Then x is equal to 0 is one of those, and y equal to 0 is another one. So x and y equal to 0, this is y equal to 0, and that's x equal to 0. How you can plot it, the hyperbolic form. But here you have x minus 2 times y equal to constant. I know that maybe it's boring for you that I'm talking about this mathematics thing, but believe me, no one tell you that. Most of the problems are just teachers are writing that in final form. Don't show you how it comes from, and that's why most of your mistakes in the exams are because of the mathematics, not because of the understanding of the fluid mechanics. I'll try to give you a complete form. I hope that it be helpful for you. So finding the tangential line, x minus 2 equal to 0, then x equal to 2. The other one is y equal to 0, right? So I will show you here that if that's my xy, that's y and that's x, okay? If that's my xy, then x equal to is going to be here. And y equal to 0 is this one. If I assume that c is positive, then that's my plot. If I assume that C1 is higher than C2, this is going to be C1, C2, in the other form. C2 should be higher than C1. C2, C3, and this is C1. And if you increase the C, this plot is coming up. if you assume that C1 is negative and C2 is smaller than C1 and C3 also smaller than C2, then this is going to be, at first, since that's negative, it's coming to this side. Okay. And also make it more negative, then it's coming more like this. Okay. And the question told you that what is the plot streamlines over the first quarter? So this is our first quarter, and it doesn't give you any limit for or concept for C. So the streamlines would be, if that's x2, then would be here. Cutting here, cutting. That much detail of plotting is not necessary, but I'll just show you the mathematics. And it's this is not something that I understand from the equation. I remember that from different questions that I saw, that how hyperbolic equations will be plotted and how the C's, if I change the C's, if the C's are positive, how I have to plot it, how it would be if C is negative. And that's from my remembering from different questions that I saw. It's not something that necessarily you have to know. But for the question, for the exam, if I give you, the only thing that I want you know is that xy equal to c has to have a form like hyperbole, right? If I couldn't find the tangential lines correctly and just give me that, hey, this is my streamlines, that's totally fine, okay? Because it also in the question asks you, told you that use a MATLAB or Excel file or something to plot that for you. So I'm not tell you that you have to know it, but it would be better if you know more about the details of that and mathematics. That would be helpful in future. And when you see the plot, you know that, hey, that's hyperbolic form. So give you better understand. Any question till now? Okay. Try to solve question 2 in the middle. It's going to be Peter Pass. In question 2, it also gave you another velocity field, UV, is 2D because it doesn't have W or cater, and it asks you that find the path line streamlines. Okay, so at first it asks you that what is the relationship to, for a particle position x and y at t equal to 0. Okay, it only asks you that what is the equation or the particle's position xy at time t equal to 0, but at time equal to 0 is doesn't mean that you have only one x. The t is at t equal to 0 is the point that the particle originates from that, right? So it's originated from time t0. It's like a function that you're plotting, like line and the one constant points, right? So if I give you that, I have x, I have like y equal to x plus c, okay? And I tell you that, okay, so this line passes through the point of 1 and 1, okay? So you replace it here and say that c should be 0. If I tell you that it's going to be 1 and 2, then you can say that the c should be 1, right? It depends on where you originated the point at time 0. because the time could not be negative. So time 0 is or your first point that the path line started. It doesn't mean that it's single point. It's a line and it has a function. It's a function of t, but it started from t0. T0 is only your boundary condition. It's one of the inputs that you can find the constant, right? And it doesn't mean that you have only one point. The answer of this one is a line. It's a relationship. So it's a function. It's not only a point. Remember that. So at first you will write that, okay, u is dx over dt and v is dy over dt. Okay, so what is my u is 8 and dy dx dt. Okay, so I can write that a dt is equal to dx. Then I can integral from each side and say that x, I'll take it this one first. X minus x0. X0, there is a reason behind that. That's why I told you that write constant from each integral separate, right? So I'll write that, okay, x minus x0 plus is equal to at plus t0, right? I take the integrals here, at plus t0, and the negative or positive doesn't matter. It's just because I want to bring the x0 other side. I don't want to have another negative minus x0 here and positive t0 and take care of the minus and positive. Then I put negative sign here and bring it here as a positive number because I know that it's going to be the other side and x would be or independent variable, okay? Because you want to write that it asks you that x as a function of t and y as a function of t. X and y are locations and function of t. So that's why I wrote it here. Again, if because you don't know which one should be the other side, then you can say that, hey, it has to be x plus x0. That's totally fine. If you bring x0 here, is going to be negative, and then you can decide that, okay, minus x0, why not plus x0? Because these are constant, and you don't know what is the number for that right now. Okay, so x minus x0, keep it in your mind. Just keep it. And take the integral for the second one. V is bt equal to dy dt. Then this is going to be bt dt equal to dy. If you get the integral from each side, then the answer would be, if I take this one first, is y minus y0 is equal to bt squared over 2 plus b0 again. And that's your second equation, okay? What is my boundary conditions? So the first boundary condition, it mentions that at time 0, so boundary conditions, least boundary conditions, at time 0, I have x0 equal to 0, and I have y0 equal to 0. Then I have 3 points to apply for t constant numbers that I have in these two equations. So t0, x0, and y0. So if I apply this boundary condition, then the second equation, the first equation going to be x minus. These are going to be 1. 1 and 1. We mentioned here, x0 is 1, y0 is 1. So 1 and 1. Then x minus 1 is equal to 8t plus 0, and y minus 1 is bt squared over 2 plus 0. Then x as a function of t is 8t plus 1, which is 2t plus 1, because a is 2, and y is bt squared over 2. This is 0, and this is 1 comes here, which is 15 t squared plus 1. b is 0.3, and over 2 is 15.15. T squared plus 1. So these are my equations for xt and yt. xt, I mean x. Part A is done, right? So part B wants to find this pass line. So pass line is very simple. When you find x as a function of t and y as a function of, that's why I'm solving this question, because it gives you part by part, and part A going to be used for part B. And it show you that how we are solving and finding the path line, okay? So it's very simple. It's not that much hard. You have two equations, x and y, and both of them you have equation for t. Okay, the only thing that you have to do is to find t as as an independent variable, as a function of the other variable, that is location, like y. So instead of having x t, you need to have t of x. Okay, doesn't matter which one that's easier. Just decide that one of these two that makes it easier, or y t, then just find t as a y. Just have a single t in one side and the other side others. Okay, so obviously that t is a square, and if I want to have the t as a function of y, so there I need to bring one here, minus one, and then over 0.15, and then the square root of that. So that's hard. So I decided to use x of t because that's simpler, okay? So what is x? Is 2t plus 1, right? So then I can say that 2t is x minus 1, and t is x minus 1 over 2. That's the step one. We found t as a function of other location, okay? One of the location. And then replace this one on the other equation that you don't use till now, like yt, okay? Instead of t in yt, which is 0.15 is t squared plus 1, replace t with the term that you find in step 1, right? So if we replace it, what we'll have? Y, this is not any function of x, t anymore, because I replaced t, right? Change the variable. So y now is a function of x, but y is equal to 0.15, x minus 1 over 2 squared instead of t plus 1, right? If I rewrite that and find this term, x minus 1 squared over 4, then y is 1 plus 3, 5, and x minus 1 squared. That's the path line. Easy. The path line is easy. Only you need to find x over t. So if I ask you that, what is the path line? And only I give you the velocity field, then the only thing that you have to do at first, u equal to dx over dt, and v equal to dy over dt. Then replace u here, v here. U and v could be a function of x, y, t, and all the variables that we have, location and time. The only part that you have to do is finding the x as a function of dt and v as a function of dt. Y as a function of t, So that's what we have done here, right? Finding the x of t and y of t. Then choose one that is easier for you to, because you want to change the variable t to x. So you want to combine these two equations. So how you have to find the t as a function of x and replace the in the second equation t with the equation that you find from the first one. So that's what we have done here. And this is going to be your password. Okay. again, that not that much hard. But what is asked you to do in part C? In part C, it asks you that determine the general equation for a streamline. Okay. So let's find the streamlines. What was the equation for finding a streamlines? dy over dx is equal to v over u. Okay. So v over u, and what is v? Is bt. And what is u is a. It should be equal to dy over dx. Then a dy, multiplying that with this. Okay, a dy is equal to bt dx. Now get the integral from each side. By getting the integral, you have a y. Again, I will choose to write it like this. There is a reason again behind that. Or I can make it simpler by writing that bring a here. Okay, so dy is equal to b over a t dx. This is also possible to write in this form, right? You didn't do something a huge thing. You just multiply by 1 over a, right? Now we can take the integral and say that y minus its constant is equal to bt over a times x minus. Okay. Then keep y on one side and bring the constant the other side. So y is equal to bt over a x minus x0 plus y. What did it tell you? That the x0 and y0 is 1. So apply boundary conditions. What is boundary conditions? Boundary conditions are x0 is 1 and y0 is 1. What was b? 0.3. And what was a? 2. You can apply that right now. So y is 1 or 0 plus 0.15 because 0.2 over 2, and also you have a t here times x minus. And that's your streamline. Now in part D, it asks you that plot that for t equal to 0, t equal to 1, and t equal to 2. Okay, it asks you to plot it. When you are going to plot some streamlines, you have to put that variable inside of the streamline equation and then find the equation for that and plot it. Because these are lines, like your streamlines. So if t equal to 0, then your y is going to be equal to 1. If t equal to 1, then y is 1 plus 15, t is 1, x minus 1. I put t here. And if that's 2, your equation for y and x is y equal to 1 plus 0.3, x minus 1. Okay, so this is going to be a simple line, a straight line. This is 0.15 x plus 0.85, and this is going to be 0.3 x plus 0.7. So if I plot it here, this is in red, is y equal to 1. This one in black, we start from 0.85 with like 0.15x plus 0.85. And the third one is going to be here. That's the blue one. Is 0.3x plus 0.7. So these are your streamlines, right? You're done with this equation, but let's plot the equation of path line because the particles are moving over the streamlines, right? So let's check that. I'll write the equation here. So what was the equation? Y was equal to 1 plus 0.30375 x minus 1 squared. Okay. I don't want to make it that much exact plot, right? But I will tell you again something from equations. So if you have a function like y equal to fx, and you have any plot for that, okay? So if you add any constant here, if it's -1 or positive or negative, right? So it moves over x. If it's positive, it moves in this way. If c is minus c, and if it's positive c plus c, it moves in this way. So plot it first, and then apply fx minus plus c. And if you add or deduct any constant from y, then it moves up and down. If it's y plus y0, y plus y0, if it's y0 is positive, it's going up. If y0 is negative, it's coming down. So for here, I just don't care that it's constant. It's like y equal to x squared, right? Y equal to x squared is simple here. That's 0, 0, okay? And x squared is here. X minus 1 squared means that the same plot, but is moving because it's -1. It's moving 1 unit to this right, okay? And if x minus 1 plus a constant like 1, it's going up, and this would be your plot, right? So first, x minus 1, I plot it, bring it here, 1, and then going up. So the same here, it's -1 here, and consider that this is 1. I don't care this because the weight that you have here is going to show that how much this is going to be closer. These two sides are going to be closer. If you have a weight, it's going to be like this, more wider plot. But that's again mathematics. Don't worry about that. So I will write it, plot it here, that it has to pass 1 by 1 and 1, right? So if that's 1 and this is 1, this is going to be a center of your function, x squared function, and this is going to be your plot here, right? It's going up and down, but it has to say that this also, maybe it's like this because it has a power constant, a small constant, so it has to be more wider. So particles starts here and moving down the, it's totally different with the streamline, right? These are totally different with streamlines. The particles start here and moving, but not over streamlines. But if you plot the streamline, the whole streamlines, like here, 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 always in any time is on one of the streamlines. Okay, it's moving, but it's moving over different streamlines. Why these two are not matched with each other? So why the path line of that particle moves are different with the streamlines? Because it's not steady. If it's a steady, path line and streamline are merged, right? Since we have in the velocity velocity field, we have t at a time, so it's not steady because it's function of t, right? Steady means that if you get the local acceleration, local acceleration is rho the derivative of u over t, which is 0, but the derivative of v over t, the second component, is b. It means that it's not 0. If it's not 0, then path line and streamlines could be different. And that's why you have, if you plot this streamlines and the path line, you can see the difference between these two. But in a simple flow like a channel or pipe flow, if you plot a path line, if a particle start here, the path line would be like this because it's steady, right? It's coming from here and over the path line. And if we start a particle here, then it's going over that. And this is path line of that particle. And at the same time is your streamline because the flow is steady. It's not changing with time. That's the difference. Any question? We are done for today. And next week, we will start, we will finish chapter 4 by understanding the meaning of Reynolds transport theorem. Thank you guys for listening. Have a good one. Bye-bye.